So hi guys, our group's name was Contigrate. That's an abstract name derived from continuous integration. And our main topic that we discussed in this presentation was security in practice. And this is our final presentation. The group members in our group are Ayushi Shah, Cherrise, Coral, Mudassir, Varsha. And these were the topics. So the first topic is done by Coral and she would be starting the presentation. Over to you, Coral.
Hello, my name is Coral, and my study topic was code reviewing as methodology for online security studies with developers, a case study with freelancers on password storage. Software developers are expected to assure functionality as well as security when completing their programming tasks. To ensure that these requirements are met before being released to the public for use, they will go through the process known as the software development lifecycle, where once the end product is ready to be released, they go through code review. During this process, the program is examined by other programmers to check for any syntax, logic, or security errors, to which the reviewer will notify the software developer to make the corrections before releasing the program. Although it's been questioned about whether they over-prioritize the functionality of the program and sacrifice the security in return, this question was answered by a research article known as Code Reviewing as Methodology for Online Security Studies with Developers, a case study with freelancers on password storage, written and researched by Anastasia Danilova, Elena Nyakshina, Anna Rosgowski, and Matthew Smith, who does an in-depth study by using code review as the method of testing the priorities of software developers in discovering what flaws needed to be corrected, and more specifically, if they noticed a flaw in the password storage of the code snippet assigned. To expand the study further, Danilova et al. Would only prompt half of the 44 participants about checking for security, and the rest wouldn't be prompted as a test to see whether this would affect their judgment and how they reviewed the code. In this study, the 44 participants would receive code snippets from Elena Nyakshina's study, which gave software developers a program task for registration functionality in a web application. So instead of the software developers creating code, they would receive code and review it as their task to check whether they can figure out that there is a insecure password storage within the code, and to verify whether their priorities are the functionality or security. Half were prompted about the task being security-based, and the other wasn't prompted to see whether this affected the study. Upon analyzing all the data gathered from the surveys and the code review, it was discovered that, similar to Nyakshina et al. Results, the software developers failed to notice that the password storage was not secure, and neither noticed nor knew how to make the password storage more secure. Just as expected, the distractions set in place for the participants to notice, as logical or syntax errors proved to be their main focus. The security criteria was ignored by the majority, and only those who were prompted for security noticed that there was a problem with the password storage. This proved to be very surprising, considering a majority of the participants stated that they strongly agree that they felt responsible for end user security when writing or reviewing code at the end of the code review. 29 out of the 44 felt that they had ensured that the user password was stored securely. Contrary to their statement, the data showed that a majority approved for the code to be released once non-security issues were resolved, meaning that they would release this unsecured code since they never noticed or thought to check how secure the password storage was for it to be released. In summary, in Nyakshina et al. Study, software developers were more focused on creating functional code based on the programming task assigned instead of assuring security. And in Danilova et al. Study, software developers, while code reviewing, still focused on correcting non-security related problems and avoiding issues within the password storage, meaning if the code functions, it can be released regardless of how insecure it may be. This study has proven that there should be more emphasis on the security aspect of programming, as well as educating software developers more on how to secure data. More specifically, during the study, it was discovered that although all software developers had experience in programming, they all lacked security knowledge, as during the survey, they were also tested about and given a question about giving the definition of hashing and salting. Although they gave the right answers, it was discovered that when they were answering, a lot of them had inactive pages, meaning that they all researched the definition online to answer the survey. Meaning, if they don't understand what hashing or salting is, it has proven how little knowledge is known about security or what is expected of them unless they are asked. Thank you.
Thank you, Coral. And the next topic is led by Ayushi.
Hi, my name is Ayushi, and I will be talking about the limited impact of visualizing encryption and perceptions of end-to-end messaging security. End-to-end encryption is an integral part of communication tools, which ensures that users are able to maintain their privacy. End-to-end encrypted communication tools that are used for email and mobile apps provide an effective countermeasure against nation-state attackers, cyber criminals, and other adversaries. With these advantages also comes concerns of usability and adoption challenges of encryption tools that are used for email encryptions and modern messaging apps. A big concern is that users have flawed views of security and privacy properties of end-to-end encrypted tools. In this article, there were 5 user studies conducted involving 683 participants on MTurk and Prolific in order to investigate 3 research questions regarding which of the messaging tools people prefer to use for confidential communications. How is visualizing encryption through the different text, icons, or animations impacting the perceptions of security, trust, and privacy of messaging tools, and the different external factors and expectations of mediating the impact of encryption visualization on user perceptions. Study 1. Use of communication tools was conducted to gain an insight on selection of communication tools that are used for day-to-day and confidential conversations. The results of the study indicated the most popular tools that are used for day-to-day confidential conversations are emails and SMS/text messages. Study 2, disclosures, aimed to investigate if a more detailed, technically correct disclosure had an impact on different contributions to the perceived security that more generous disclosures that are still connected to messaging security. The results of the study suggested that the encrypted disclosure condition was much more preferred by participants because it made them feel more secure compared to different disclosures that did not have more significant impact on the usability and satisfaction. Study 3, icons, seek to investigate 3 different icons and study their impact on perceived trust, security, and privacy and usability. The results of this test indicate that there was a negative effect of security icons on trust, security, and privacy by 0.47 points compared to the baseline. Participants who have a background in computer science particularly disliked the security icons that were investigated compared to those without a computer science background. Study 4, animations, studied 3 different animations of encryption. This study was conducted because of the results obtained after the first study, which implied that the dynamic animations of the encryption process can increase perceptions of trust, security, and privacy. The results of study 4 suggested there was a positive effect of circle on users' perceived trust, security, and privacy, and security animations had no impact on the usability and satisfaction. Lastly, study 5, validation, was to validate the results from studies 1 through 4, while also addressing the limitations that came across with the whole process. The limitations of the studies conducted came from the fact that studies were largely based on the responses of the US internet users. The results of study 5 confirmed the findings of studies 2 through 4. Visualizing encryption in any way, even a simple text disclosure, improves perceptions compared to not mentioning it at all. Most participants saw the animations and felt they communicated security, yet they did not change their perceptions any more than a text disclosure did. An app's reputation greatly impacts perception. Prior to the studies, the authors assumed that visualizing encryption through various text descriptions, icons, and animations of the encryption process would allow there to be improved perceptions of trust, security, and privacy. However, they were disappointed by the studies that indicated that simple modifications of messaging apps, UIs, are unlikely to help users better assess app security and privacy. Thank you.
That was great. Now on to topic 3 by Varsha.
Hi, my name is Varsha, and my article was Concerned but Ineffective, User Perceptions, Methods, and Challenges when Sanitizing Old Devices for Disposal. In today's era, technology plays a major role in everyone's lives and has continuously grown to be a specific part of their day-to-day. These devices hold valuable information as well as personal information and comes in different versions like flash drives, phones, laptops, etc. Given the fact that they're more accessible now, people tend to own more than one. As they upgraded their devices, they tend to have their old one laying around with their personal information stored inside, which would lead to potential risk of identity theft or just leakage of personal data. The authors claimed old devices needed to be sanitized before selling, donating, throwing away, or recycling, but previous works have shown that users frequently fail to do so. They provided suggestions for device manufacturers and retailers on how to improve privacy, trust, and convenience when sanitizing old devices. However, they didn't provide suggestions to the users because everyone has their own beliefs. In order to gather a fair amount of data, the participants were between the ages 18 to 50 and self-reported how proficient they are in technology, with the levels being basic, intermediate, advanced, and undisclosed. Over 35% chose to keep it as a backup. 35% kept it for privacy concerns. 20% said it wasn't worth the hassle, and 5% chose other. Another question asked was, did you remove any personal data on your old device before selling, giving away, recycling, donating, or returning it? 60% said yes, they factory reset. About 20% claimed deleted some data or secure, and roughly 20% said they either trust the recipient, said no, that they either trust the recipient, device encrypted, or just not concerned. It was discovered that the majority of the people used the factory reset button, and for those that deleted information manually, missed out on certain things. If the device was a phone, users covered the basics like photos and contacts. However, they skipped over deleting browser history and saved passwords, which is still personal data that others have access to. Bias played a role because not many people would be comfortable telling the truth about how they dispose of their personal information on old devices. Giving the desirable answer was what they probably did, because the participants were the only ones that knew that. A solution the authors believe is that when it is time to delete something permanently from the phone, a message should pop up to warn that user that they'll never be able to access it again. Also, the information given to the users before the factory reset should be reconsidered and include more details. Either that, or give the user another option, for example, to reset the device due to the issues or reset it in preparation to sell. When it comes to sending the phone to the resellers, the previous owners would rely on them to sanitize the phone. Towards the end of the study, a new problem was discovered. People have access and control to the deletion process of their phone on their devices, but do not have the same access when it comes to deleting information stored in the cloud. Their quick solution was to make an effort and focus on the problems and carry out another investigation for those specific devices that store data in the cloud. That concludes my article. Thank you.
That was topic 3 by Varsha, and now off to topic 4 by Cherrise.
Thank you. Hi, my name is Cherrise, and my topic was benefits and drawbacks of adopting a secure programming language. Cyber crimes have multiplied with the expansion of the internet, leading companies to focus on security measures. With this in mind, security specialists have worked on hardware and network level security advancements. However, software security is often not the priority. Software development has been a lucrative field for a long time, but vulnerabilities remain a huge issue today. Most companies focus on the efficiency of the product and sales procedure and not on needed security until a breach or attack happens at the company. By improving security, the company can ensure their customers are having a great experience and generate more clientele in the future. In this article, the authors are recommending that we use Rust as a solution to this problem. Rust is a memory-safe, compiled programming language that delivers high-level simplicity with low-level performance. It's a popular choice for building systems with critical performance, such as game engines, databases, operating systems, and is an excellent choice when targeting WebAssembly. It doesn't have a garbage collector, but achieves memory safety with a concept known as ownership and borrowing. Every variable in Rust is immutable by default, and this allows values to be used in the stack memory with minimal performance overhead. However, mutable values or objects with an unknown size at compile time are stored in the heap memory. Every value in a Rust program is assigned to a single variable, These variables are known as their owners when the variable goes out of scope. The purpose of this programming language is to create great code while making secure software at the same time. One of the key features of Rust that sets it apart from other new programming languages is its memory management is manual. The programmer has explicit control over where and how memory is allocated and deallocated. Pure Rust code offers the best performance between the two, and it's around 12 times faster than Python. Its performance matches that of C and C++, and Python is slower in comparison. Rust also provides developers with a good combination of high performance and security when compared to Python, and it proves processing speeds. With the Rust compiler, you just build a memory-safe executable that can handle the most performance-intensive system requirements. Thank you.
Perfect. That was great. So now off to the last topic, 5. That's by me, Mudassir. And the topic was an analysis of the role of situated learning in starting a security culture in a software company. This research was done by these authors, Anvesh Soladar, Daniel Lende, Jay Legati, Jinmeng O, and these guys conducted an ethnographic study of the software development of a software development company. The summary of this study was they explored how a development team adopts security practice into the development lifecycle. Their study was focused on the software development and security culture in this company. That meant they looked at both the departments, like the development side and the security side. Further, they assessed how things worked in the real world. They also looked at the security expert working within the development team. They figured out that the security expert working within the development team was an instrumental, in driving the positive shift in the culture. These researchers implemented the method of participant observation. Before I get onto my conclusion, I wanted to discuss a few terms. AppSec, that's used in this research a lot. So AppSec is the process of finding, fixing, and preventing security vulnerabilities at the application level in the hardware, software, and development processes. Threat modeling, a procedure for optimizing application, system, or business processes security by identifying objectives and vulnerabilities. Security Scrum Poker, a consensus-based gamified technique for estimating, mostly used for time boxing in agile principles. And Agile is a time box iterative approach to software delivery that builds software incrementally from the start instead of trying to deliver it all at once at the end. Sprint is a procedure in Scrum. Basically, it is a short period of time wherein a development team works to complete specific tasks, milestones, or deliverables. So I wanted to discuss this diagram below that shows that how the company went on from threat modeling to security Scrum Poker, and then working on the context in which they started including sprint in security in the sprints, and they successfully created a security aware development. So the research started with the researcher saying that this company didn't have a security culture when they first arrived. And they saw the transition from the manager recognizing the importance of security and then gradually implementing using these technologies which were mentioned in this diagram, and they became a security aware development company. In conclusion, the authors of this study successfully conducted an ethnographic study investigating how a software development company establishes a security culture in the practical world. Through the study, the main findings were that although having a security expert working within the development team is instrumental in driving the positive shift, but it has some limitations. Those limitations can be like spending more time on security rather than development, and other stuff like focusing on your company tasks rather than development sprints rather than the security sprints. Because if you see in a software culture, there's always many developers that don't give similar importance to security as they do to their product. So that is why these were some of the limitations that they found. However, there has been earlier research on this similar topics, but this research was different in a sense that in this research, the researchers implemented the method of participant observation because the person researching was inside the company and took a look at how things work. And in conclusion, the study found that this security culture had grown because of the practices that they adopted, like security Scrum Poker, and then applied them in the practices, which helped them in long term. So basically, this was the end of our presentation, telling the security practice in the practical world. And we would like to thank you to stick around and take a look at all our topics. And once again, thanks to all my group members, and we would like to end the presentation over here. Thank you.